Hi Dr. Gao. This is the Comp 173 final project demo, and this project is a solution to the synchronization problem at the San Diego Zoo. So I'll go ahead and run the program. And here is the output. So I'll scroll up to the first set of data, and there we go. And so initially all of the cars are at the gas station because the gas station is full. So in this set of data we have 35 visitors, 6 cars, 5 time units for each ride, and 2 gas pumps. So the way the gas thread works is it initially takes k cars from the queue and places each one at an available pump, and then it prints this message that says which pump is occupied, as well as the number of cars that remain in the queue. It then simulates the amount of time for a car to be filled up with gas, which is 3 time units, and it frees the corresponding pump, and it prints the message as well as displays the total number of cars that are still fueling. So the gas thread continues this procedure until all the cars in the queue have been serviced, and then at that point we have all of the cars are available and are free for use. So the car thread begins, which is sort of the main control structure for the entire program. The way the car thread works is it takes the first n visitors from the visitor queue and places them in one of the available cars. We have n cars available, and so it also its output, it says, is the visitor number and what car they're on, as well as the total number of cars that are currently out on rides. The visitor thread then simulates the actual ride of t time units, and its display is to show which visitor returned from their ride and the total number of visitors that are left in the queue. The visitor thread also frees up the car that was being used. So this process continues until all of the visitors in the queue have been serviced, and at the point when the cars need refilling, each car needs to be refilled after 5 rides. So if we have 35 visitors and 6 cars, we know that after we serve the 30th visitor, each car would have gone on at least 5 rides. So if we scroll down here, you can see that after the 30th visitor returns from their ride, the gas station thread starts again, and it begins servicing a queue of cars. And once the cars are refilled, the car thread takes over once again and services the remaining visitors in the queue. And underneath here we just have a second set of data, and I believe for this set of data we had a total of 19 visitors, 4 cars, 10 time units per each ride, and 3 gas pumps. So this is just another run, and it functions in the exact same way, with the gas station being initially full and servicing the queue of cars. And if we scroll down, we'll see that after there's no more data left to be run, main exits and displays this message that all runs are completed. So the implementation of the solution here, I just list some of the resources that I used to learn a little bit more about semaphores and mutexes. I defined a new type called car, which is a struct, and it just keeps track of important information about the car as well as the current ride. Num rides just keeps track of the total number of rides that the car has gone on. If it's equal to 5, then the car needs to be refilled at the gas station. Status is just a binary number, 0 or 1, indicating whether the car is free for use or if it's occupied. And visitor index just keeps track of the current visitor that is riding the car. Here are the semaphores, S1 and S2. S1 is representative of the car's resource. It contains the total number of cars. S2 is representative of the pump's resource. It contains the total number of pumps. So here we read in the data on main and store the data in the appropriate variables. If the data is null or the row is all equal to zeros, then we break out of this loop and exit the program. Otherwise, we allocate the arrays, the visitors, cars, and pumps arrays. We initialize them, and we also initialize the semaphores here. So S1 is initialized to n, which is the total number of cars, and S2 is initialized to k, which is the total number of pumps. Here's the car thread. This is the main control structure for the program. So the car thread runs while there are still visitors left in the queue, using this while loop here. And if it's our initial run, then we actually initialize the number of rides for each car to 5, because we want the cars to go to the gas station so that the gas station is full when we first begin. And the way the car thread functions is it takes the first n visitors from the queue, using this for loop here, and places them in one of the vacant cars. Each time we place a visitor in one of the vacant cars, we consume the car resource, which is why we have this call to wait. The visitor thread then takes over, and this simulates the actual ride. And we simulate it with a while loop. So while the counter is less than the time unit for a particular ride, we increment counter. And once the cars have taken the visitors on their rides, we have to replenish the car resource and return the visitors back. So here we replenish the car resource using post, and we free the car up. The gas thread functions in a similar manner, only instead of servicing a queue of visitors, the gas thread services a queue of cars, and instead of providing the resource of a car to a visitor, the gas thread provides a resource of a gas pump to a car. The first thing the gas thread checks is if there is enough gas at the gas station. If the total number of fills is greater than or equal to 150, then the station must be refilled and the gas truck is needed. So we simulate the gas truck refill here with this while loop, and it's 15 time units for a gas truck to refill the station. Otherwise, we go ahead and service the queue of cars. So while there are cars inside the queue, we go ahead and occupy the first k pumps with the first k cars in the queue, and we consume a pump resource each time we place a car at the pump, and we consume it here with the wait call. And then we simulate the fueling for one car with the counter variable here. Now once the cars have been refilled, we go ahead and free the pumps. We replenish the pump resource here by calling post, and we go ahead and reset the number of rides for each car back to 0 because it's now refilled and available for use. So that's pretty much the program. Something to note also here maybe is the total number of visitors is completed, but the pump goes ahead and still fills up the cars, and that's because the gas thread is run after the main car thread runs. So In fact, after visitors 17, 18, and 19 returned, looks like the first 3 cars needed refueling, so the gas station thread runs. And that's pretty much all, Dr. Gao. Please let me know if you need me to describe the solution in more detail. But I just wanted to thank you for taking the time to teach us operating systems over the summer. I really appreciate it. I really enjoy all of the material from process and thread synchronization to memory allocation, and learning about scheduling algorithms is all very interesting. So thank you again for your time. I really appreciate it. Thanks again, Dr. Gao, and I'll go ahead and close the video now.